Hello everyone, welcome back to my YouTube channel. In this video, I want to continue to solve past paper from EJU Mathematics 2018, first session, course 1, question number 2 from section 2. If you want to watch the other solution from this past paper, you can check link on the description box below, or you can also check my EJU playlist if you want to find out another past paper for EJU preparation. Before I start, don't forget to like, share, and subscribe my YouTube channel if you like my video. Okay, in this question, we will let a be a constant other than 0, and then let f of x is equals to blah 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 and g of x is equals to blah blah blah. So we are given a quadratic functions. The first one is f of x and then the second one is g of x. When the solution of f of x equals to 0 and the solutions of g of x is equals to 0 coincide, then a is equals to blah 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 and their solutions are x equals to blah blah blah. So for the first question here, we want to find the value of a for which the solution of f of x and g of x to be equals to 0 are coincide. As you can see, solution of f of x equals to 0 means we want to find the value of x where this parabola cuts x-axis. Same thing for g of x equals to 0. So, since the solutions coincide, that means the x-intercept of both parabola is equal. You can imagine if you have two parabola, I will give you an illustration here. If you have two parabola, let's say this is the first one, and then this is the second one. I will assume the second one is concave downward like this. If the x-intercept are coincide, that means the symmetrical axis must also the same. Of course, you can draw another parabola. For example, you can draw parabola like this. For example, if this parabola have same x-intercept, that means the symmetrical axis will also the same. So, to find value of a here, I need to find symmetrical axis of the first parabola, and then I need to find the symmetrical axis of the second parabola, and then we will equate them. Don't forget, if you want to find symmetrical axis, we have formula x symmetrical is equals to minus b over 2a. b is the coefficient of x and then a is the coefficient of x squared. So, symmetrical axis of f is negative b. b is 2a here. So, negative b over 2a. The coefficient of x squared is 1. So negative 2a over 2, while the symmetrical axis of my second parabola is negative b, which is 2, over 2 times a. The coefficient of x squared is a, so 2a. And then just equate them, then I think you can find the value of a. If I equate them, I will get negative 2a over 2 is equals to negative 2 over 2a. You can cancel out negative sign here, and then you can cancel out 2 and also this 2. Then a is equals to 1 over a. By cross multiplying this equation, you will obtain a square is equals to 1. Therefore, a is equals to plus and minus 1. Plus minus 1. Don't forget, yeah, if you want to get rid the square here, so the other side, we will square root the other side, but don't forget to put plus minus sign. So in this case, I have two possibilities for a. The first one is a equals to 1, and then my second one is a equals to negative 1. Since a here consists of two term or two expression, then I think my final answer is negative 1. So this is my answer for a. I will reject it, a equals to 1. Of course, there is a reason why a equals to 1 is being rejected. You can comment below if you know the answer, and I will pin your comment if you got the correct answer. Okay, so for the first question, a is equals to negative 1, and then for a equals to negative 1, we need to find the solutions. Of course, the solutions will be the same number. So just put a into either f of x equals to 0 or g of x equals to 0. I will put it on f of x. F of x is this one, and then if you substitute a by negative 1, you will get x squared minus 2x minus 4 times minus 1 minus 12 equals to 0. We need to find the solution of this quadratic equation. If I simplify it, I will get x squared minus 2x plus 4 minus 12. Plus 4 minus 12 is minus 8. And then I can factorize them into x plus 2, x minus 4 equals to 0. So my final answer is x equals to negative 2. This is the first one. And then the second one is x equals to 4. So you already find OP and Q here. OP is negative 2. And then P is 4. This is my answer for the first question. Let's proceed to the next question. In other case, g of x equals to 0 has just one solution when a equals to blah blah blah. And in this case, the solution is x equals to blah blah blah. So for now, you can forget the f of x, because for the second question, we do not need f of x. We just need the g of x equals to 0. So this expression is equals to 0. So I have ax squared plus 2x minus 4a plus 4 is equals to 0. For this quadratic equation, to have just one solution, the condition is its discriminant must be equal to 0. So for a quadratic equation, to just have one solution, the discriminant must equal to 0. The formula of discriminant is b squared minus 4ac. b squared minus 4ac. This is the formula that we can use to know the discriminant of a quadratic equation. Discriminant must equals to 0 b is the coefficient of x. In this case, coefficient of x is 2, so 2 square, minus 4 times a is the coefficient of x square, which is a, 4a, times c. C is the constant, so c is negative 4a plus 4. Negative 4a plus 4 equals to 0. By solving this equation, I'm pretty sure you will get the value of a. First of all, I can divide all the terms by 4. If you divide all the terms by 4, this one becomes 1, and then this one also becomes 1. And then I will get 1 minus negative 1 times negative 4a, you will get plus 4a. And then negative 1 times 4, you will get negative 4. This is a, yeah? This is a. And then minus 4 equals to 0. 1 minus 4 is negative 3, and then you will move the negative 3 to the other side. It becomes 4a equals to 3, then a equals to 3 over 4. So R and S is 3 and 4. R is equals to 3, and then S is equals to 4. Once we know a is equals to 3 over 4, we can find the solution of g of x equals to 0. Since I already know a equals to 3 over 4, I just need to substitute a to my first equation. Then I will get 3 over 4x squared minus 2x minus 4 times 3 over 4 plus 4 is equals to 0. Then, oops, I'm sorry, I think I made a mistake, yeah? I'm sorry for this careless mistakes. If you see here, we have a, and then negative a times negative 4a, it becomes 4a squared here. I think I need to redo my working. Negative a times negative 4a, we got 4a squared. And then negative a times 4, you will get minus 4a equals to 0. I think this is the correct one. Sorry for my careless mistakes. And then, since we want to find the value of a, I just need to factorize this quadratic expression. 2a minus 1, 2a minus 1 equals to 0. Then a is equals to half. I think this is the correct one. So, instead of 3 over 4 here, I will change it into 1 over 2. I think this is the correct one. And then, in this case, for a equals to half, the solution is equals to blah blah blah. Now I will substitute a by using half. Then I will get half x squared plus 2x minus 4 times half plus 4 is equals to 0. And then we need to solve this quadratic equation. I will simplify it first. I will get half x squared plus 2x minus 2 plus 4, you got plus 2 equals to 0. By multiplying all the terms by using 2, you will obtain x squared plus 4x plus 4 is equals to 0. Once again, by using factorization, I will obtain x plus 2 equals to 0. Therefore, x is equals to negative 2. This is my final answer for letter T and U. So T and U here is negative 2. Okay, let's continue for our last question. They want us to find the range of A such that f of x less than g of x for all x is blah blah blah. We need to find the range of value of x for which f of x is less than g of x. So, if you imagine from the diagram or the graph, we want to find the condition for which f of x is below, in graph less than means below, g of x. F of x is below g of x. If I give you an illustration here, we have two parabola. The first one is f and then the second one is g. I will assume this is f, and then this parabola must below the second one. Below the second one means the second parabola here must be something like this. So f of x is below g of x means these two parabola has no point of intersection. If they intersect with each other, let's say I will draw my second parabola like this, for example. If they do have intersection like this, that means there is a condition or a range where f of x is above g of x. While in this case, I want f of x is below g of x. So, my point is, if these two parabola intersect with each other, then this inequality is not correct. So, for f of x is below g of x, that means these two parabola cannot have point of intersection. If I assume we need to find the point of intersection, then I will just equate the expression. So, assume I want to find the point of intersection. To find the point of intersection, I will equate f of x equals to g of x squared plus 2ax minus 4a minus 12 is equals to ax squared plus 2x minus 4a plus 4. This is how I find the point of intersection. But since I do not want these two parabola intersect, that means this equation must have no solution. For this equation do not have any solutions, then the discriminant must less than 0. So first, I will rearrange this expression or this equation first. I will move this into the other side. I will get x squared minus ax squared plus 2ax minus 2x minus 4a plus 4a. We can cancel out this one, and then minus 12 minus 4 you get negative 16 equals to 0. And then I can factorize x squared. I will obtain 1 minus ax squared. From this expression, I can factorize x, then I will get 2a minus 2x minus 16 equals to 0. Since I do not want this solution or this equation to have solution, because as I say earlier, yeah, for f of x less than g of x, that means f of x do not intersect with g. Since f do not intersect with g, this equation must have no solution. For this equation do not have any solution, then the discriminant must less than 0. The formula of discriminant is b squared minus 4ac. Then this is b. So 2a minus 2 squared minus 4 times a times c less than 0. By solving this inequality, I think we can find the range of a. First of all, I think I will expand this expression first. If I expand it, I will get 4a squared minus 8a plus 4. Negative 4 times negative 16, you get plus 64. 1 minus a less than 0. You can divide all the terms by 4 to make our equation more simple. Divide by 4 becomes 1. I divide it by 4 becomes 2. I divide it by 4 becomes 1. And then I divide it by 4. You got 16. And then a squared minus 2a plus 1 plus 16 minus 16a less than 0. A squared minus 18a plus 17 less than 0. If I factorize it, I will get a minus 17, a minus 1 less than 0. Then I will get two critical values. I will get two critical values. The first one is a equals to 17. The second one is a equals to 1. Since we want to find the solution of inequality, we need to draw or use number line. Our first critical value is 1. And then my next critical value is 17 here. And then you need to check the sign on each region here. If I substitute 18 to my expression, 18 minus 17, 18 minus 1, then the sign on this region is positive. By using the same method, you can check the sign in this region by substitute, let's say 2. 2 minus 17 times 2 minus 1. Then your answer is negative blah blah blah. So the sign here is negative. And then the sign on my last region is positive. Since we want my equation less than 0. Less than 0 means I will take the negative region. So my final solution is 1 less than a less than 17. So V is 1 and then W and X is 17. So this is 1, this is 17. Okay, this is the answer for my last question, and also this is the end of this video. Thank you for watching this video till the end. I hope I can see you guys on my next video. Bye bye.